Today we're going to be continuing section 7.2, working with rational exponents some more. And basically we're just going to re-emphasize what the rules of exponents are and use them just with rational exponents. So if you need to remember what they are, you can always go to your book and page 421 and take a look at those there, but we'll be reviewing them as we go as well. So if I take a look at number 1, I'm multiplying and I have the same base. So if you recall, what we're going to do is we're going to add the exponents. Now I have rational exponents, so it's 1/3 plus 1/4. And if you remember, you need common denominators. So I'm going to change that. Common denominator will be 12, so this will be 4/12 plus 3/12. So I'm going to reduce that. So it's x to the 7/12. Now, that's fine to reduce it like that. In the last video, we were talking about converting them into radicals. This also could be converted into the 12th root of x to the 7th. But the the rational exponent would be fine as well. All right, when we talk about number 2, now I could try to reduce 9 2/5 and 9 to the 12/5 each individually, but they are the same base and we're dividing. So if you remember what we do when we're dividing, when we have the same base, is we're going to subtract those. So I'm going to have 9, I'm going to do 2/5 minus 12/5, and that's going to give us 9 to the negative 10/5, which is really 9 to the negative 2nd. And because we don't want negative exponents, that's going to be 1 over 9 squared, which will be 1 over 81. Number 3, very similar to number 1, we have those rational exponents. We want a common denominator, so we're going to do negative 3/10 plus 6/20. Common denominator is 20, so it's negative 6/20 plus 6/20. You'll notice it cancels out, so it's going to be y to the 0 power. So what that means, if you remember what anything to the 0 power is just 1. Go ahead and pause the video, try to do these 3, see how much you remember from those exponents, and then take a look in just a second. Number 4, when you have an exponent to an exponent, remember you need to multiply. So what you're going to get is 11 to the 6/9, and that will be 11. We'll just reduce it to the 2/3 power, and I can make that into the cube root of 11 squared. Now I can't take the cube root of 11, so we'll do the cube root of 121, and we'll leave it just like that right there. Number 5, same sort of thing. I'm going to distribute that exponent, but remember that 3 also has a 1. So it's going to be 3 to the 3rd, x to the negative 2nd. Those 3's would cancel out there. And then I don't distribute to the denominator, so it's x squared. I'm going to move my negative exponents, so I'm going to get 3 cubed, x squared, x squared. Remember, that gets shifted down. So I'm going to get 27 over x to the 4th. And finally, number 6. What's going to happen is I have a number on the outside, so I'm going to take this number and distribute it. Now, since I'm distributing, I'm multiplying. And since I'm multiplying with the same base, I'm adding those exponents. So for the first one, it's going to be x to the 3/4 plus 1/4. And then minus x to the 3rd plus 3/4. So what we're going to get here is x to the 1st minus to the 15/4. Not similar, not like terms, so we can't put them together, so we're going to leave it like that. Now, if we see something like number 7, you'll notice it's two binomials. So we go through that process just the same. We're going to go through the FOILing process, multiplying the first terms together. And when we're multiplying the first terms, we're really adding. So 1/4 plus 1/4 is 1/2. I'm going to do the outer terms. So that's -7 to the 1/4. And then the inner terms is plus x to the 1/4. And then the last, which will be -7. So we're going to get x to the 1/2 minus 6x to the 1/4 minus 7. And again, you can change those into radical expressions or leave them as rational exponents. Just make sure to follow the directions that it states in the book or on a quiz or a test. Another question that you're going to see is factoring x to the -1/3 or factoring any exponent out. And basically what that means is you're just dividing it out. So if I'm taking out or dividing by x to the -1/3 from each of the terms, I'm dividing it. So in the first one, if I'm taking it out, the x's will cancel and you're going to be left with 7. Now, if I do that to the second one, I'm dividing again, but they don't cancel out, so you got to kind of think of what it means. It means that we're subtracting the exponents. 5/3 minus a -1/3, so that becomes double negative. So that's going to become 6/3, or else just 2. So we're going to get minus 5x squared if we factor out that x to the -1/3. Finally, we're going to use rational exponents to simplify. We're going to basically do the opposite of what we were doing yesterday. I'm going to take the radical and I'm going to change it into an exponent. So the y is there, exponent becomes the numerator, index becomes the base. That becomes y to the 1/2 power. I can do the same thing here. I can do 9 to the 1/4 power. Another way, though, to kind of work with this is to know that 9 can be written as 3 squared. So now I have 3 squared to the 1/4, which is then 3 to the 2/4, or 3 to the 1/2. And so what I'm going to get is the square root of 3. Over here, same sort of thing. I'm going to apply it. I'm going to make them rational exponents. 3/9, and then I'm just going to reduce. I get a to the 2/3, b to the 1/3. Now, because these do have the same denominators, you can go back and change it back into radical notation. And finally, the last few questions of the video. We're going to use rational exponents to kind of simplify these to take these radicals into one single format. So what we're going to do is I'm going to change these into radicals. I'm going to change square root of y to y to the 1/2, and then change the 3 to 3 to the 1/3. Now, in order to do the same radical, you need to have the same base, because that's what kind of pulls them together. Well, we can do this by making a common denominator. So I'm going to take this, change this to y to the 3/6, and then 3 to the 2/6. Now, since now they have the same denominator, I can pull that denominator out here, because they're the same, and now apply them, the base, underneath the radical into the radicand with the exponent. Which would be the 6th root of 9y cubed. We'll do the same thing with number 13. I'm going to have x to the 1/3 over x to the 1/4. Again, we're looking for common denominators, so we'll change this into x to the 4/12 over x to the 3/12. And we can actually do the subtraction right away and get x to the 1/12 and put it underneath the radical. Square root, the 12th root of x. Go ahead, pause the video, see if you can get number 14. So hopefully you changed the square root of 5 into 5 to the half power times 2 to the 1/3. I'm going to look for that common denominator, which is 6. So 3 6 times 2 to the 2/6 power. And so my index is 6, and I'm going to get 5 to the 3rd times 2 squared. Well, 5 to the 3rd is 125. 2 squared is 4. So if I multiply that together, that's going to actually give me the 6th root of 500. So I'm going to evaluate that all the way.